Imagine handing a 12-year-old, like, a flat, dense brick of bread and then a fluffy loaf and telling them, I'm not going to teach you chemistry today.
Right. Just good luck.
Exactly. You're going to figure out what happened to this bread on your own. And that is actually the radical new reality of middle school science. So, welcome to today's deep dive. We are looking at a stack of really fascinating educational blueprints today.
Yeah. Specifically, this multi-state initiative called SIPS CASIA
hmm
and a narrative-driven curriculum called BioForge.
Right. And our mission for you today is to explore how modern education is rewiring science class. From a boring memorization factory into a real-time investigative laboratory.
To really see how this works, we have to look at that SIPS CASIA project. So Nebraska, Alaska, and Alabama are collaborating to replace traditional tests with what they call three-dimensional learning.
Okay, wait, I'm stopping you right there. Three-dimensional learning sounds like pure academic jargon. I mean, what does that actually look like for the kids staring at that dense loaf of bread?
Fair point. So in the old days, learning was one-dimensional, right? You memorize a fact. Three-dimensional learning forces students to combine a core, idea-like chemical reactions with a practice, like data collection,
Got it.
all to understand a broader pattern, like cause and effect. So it's the difference between memorizing the textbook definition of yeast and actively investigating why one loaf rose and the other didn't.
So instead of handing them the answers, you hand them an anchor phenomenon.
Exactly. The anchor phenomenon is the puzzle. It could be that flat Irish soda bread,
Right.
or it could be handing them an owl pellet and saying, reverse engineer the energy flow of this ecosystem. Right?
Wow.
The goal is to trigger this chain of sense-making. They have to poke, prod, measure, and hypothesize the underlying mechanisms themselves.
But taking those high-level standards and successfully dropping them into a seventh-grade classroom is a massive leap. I mean, how do you keep 12-year-olds engaged in complex sense-making without them just tuning out?
Well, that is exactly the problem BioForge tries to solve. It takes these really rigorous practices and wraps them inside a narrative vehicle.
Yeah, looking through these sources, BioForge reads less like a textbook and more like an escape room. You aren't given a manual. You're recruited into an eco squad, told to reactivate an abandoned field station, and just given the tools to find the code yourself.
And the brilliance is how it builds psychological safety.
Yeah.
Unit 1 revolves entirely around this one question: what makes someone a scientist before they know all the answers?
That's a fascinating framing. It really takes the pressure off being right on the first try.
It shifts the focus entirely. Science is not a list of facts, it's a disciplined operating system. And you see this perfectly in their final Unit 1 project, where they have to create a trustworthy science field guide.
Right, and the tone of this project is so specific. They're spoken to by a mission commander. It's very calm, capable, evidence-focused, no childish enthusiasm or fake emergencies.
Exactly. The commander tells them to build this guide to teach another investigator how trustworthy explanations are built. And they have to follow a strict sequence.
Observe carefully. Ask a useful question. Choose the right tool and scale. Gather evidence.
Yes, and then build and revise models. And they use CER, which is claim, evidence, and reasoning. But the coolest part is they don't start from scratch. They reuse artifacts from their mission archive.
Like their observation and inference work.
Yeah, and they have to include a history of science requirement. So they might use the invention of microscopes or the shift from spontaneous generation to germ theory to explain how people's models changed when new evidence or tools appeared.
Wait, I have to jump in. That is incredibly difficult. Even adults constantly struggle to separate what they literally see from what they assume has happened.
Oh, absolutely. But they make it highly visual. If they sketch a microscopic object, they are penalized for writing down guesses. They label only the literal shapes and colors, putting a strict boundary between pure data and inference.
Because if your observation is tainted by assumption, your entire scientific model collapses.
Right. They learn that scientific trust doesn't come from certainty. It comes from making your evidence, methods, and revisions completely visible so another investigator can inspect them. Artistic polish doesn't matter. Clarity and evidence do.
So, bringing this all together, the ultimate takeaway is that scientific identity isn't about already knowing the answers. It's a learnable set of practices. Noticing carefully, recording honestly, and revising when evidence shifts.
It's a cognitive toolkit that goes far beyond a 7th grade classroom.
Completely.
Hmm.
Which brings me to a final thought for you to chew on. Imagine if we, as adults, applied this middle school BioForge protocol to our daily consumption of news and social media.
Oh, wow.
Right. If we strictly separated our literal observations from our emotional inferences and happily revised our mental models the second new, credible evidence appeared. How radically would that change the way we argue, vote, and interact with the world?